And we are back for part 3 and our final part for this tutorial. Finally, we're going to go over rendering and compositing of the final piece and putting everything together that we've been working on this entire time into something looking really nice. So let's get started. We are back here where we left off in the last video, and we're going to start bringing this into Solaris. So to do that, we're going to go back into our objects level, and let's be a little neat here. We can rename this to our LED creation video. Let's say, why not, right? And now we're going to go from OBJ to stage. Stage is Solaris. It is the way that you can render in Karma within Houdini. So we're going to do a SOP import, and we're going to rename this to import gumball active, and then we're going to find the path that we are bringing in. So in this case, it's going to be out to LOPs. Cool. And under our import path prefix, we're going to change this to environment /$OS. So if you notice here in my scene graph path, we created a hierarchy where everything is coming underneath our environment. Then we're going to drop in a SOP import as well for our static gumballs. However, before we do that, let's go into our sub layer style. The reason this is complaining is because this SOP network doesn't have a save path. So we're just going to merge SOP layer into existing active layer. Give it a second there to calculate, and it's gone. And then one more thing I want to do is also go into my packed primitives and create point instancer. That should help our scene run a little bit more smoothly. Give it a second here. So we're going to do the same thing here with our static gumballs. So we can do import gumball static. And we're going to do the same thing here. Under our import path prefix, we're going to change this to environments. Merge SOP into active layer, primitive definition, packed primitives, create point instancer. We're going to go ahead and find our gumballs. You can go back into our OBJ, go in here, and it is this one. Yes. So we're going to Control C to copy, go back into our stage, and we can just paste it here in our SOP path. And we look at this. Where is it? I don't know where it is. Oh, there it is. Took some time to get in there, but we got it. One more thing I want to do to have this run a little bit smoother is if I go to back into my OBJ, going here, let's just add an unpack. So I'm gonna load here a little bit. We're gonna go back into our stage contacts. Give it a second here to load everything in. Right, perfect. We're able to navigate our scene a little bit easier now. So now we're going to start setting up our scene. So we're gonna add our material library. Give it a moment here. I want my materials to exist within my environment tab, just to have our hierarchy a little bit organized. So inside of here, we're going to drop a Karma material builder. Give everything a moment here to calculate. We're going to optimize this a little bit more. We're just going to go ahead and hide our static gumballs for now. And we're going to leave our top half for the time being. We're going to go in here. We're going to call this gumball. Leave it at gumball. We're going to dive inside, and we're going to start applying our material. So in order to have an attribute that we created earlier on affect a material in LOPs, we have to create something called a USD prim bar reader right here. And in Solaris, the attribute that we created earlier in Houdini that stores our color is CD. However, in Solaris, it's not CD, it's actually display color. And we can call it by saying display color. So it's everything is together and capital C for color. We're going to leave that as a vector because it is color that holds an RGB value. And we're going to bring this into our base color here. And we're going to bring this to be our emissive color as well. Now, that attribute that we created earlier that has some of our gumballs be emissive and others not, we're going to do the same thing where we're going to drop a USD print bar reader. It's going to be an integer because remember our emissive attribute is an integer and it was called emissive. And we're going to go ahead and drop this into our emission color. Oh, no, I'm sorry, not emission color. It was actually supposed to be emission. So that means that some of my gumballs are going to be emissive and others are not. And then from there, we're going to drop and multiply. Because I want this to control how emissive I want my gumballs to be. So right now it is emissive of 1. But we're going to just bring this up to 1.5 for the time being. I'm going to bring this up. And right now, that material that we created isn't actually attached to our geometry just yet. In order to have it attached to our geometry, you have to do an assign material and our primitive. So in this case, it's going to be our gumball active. So we're going to drop this into our primitives. And then our material is going to be our gumball. We're going to drop this in here. And now you're not seeing much of a change. In fact, we actually lost our color. But if, for example, let's drop in a light here. And we're going to dot and merge. We're going to use one of the lights that already come with Houdini. It's going to be, oh, I'm sorry, not this light. It's going to be an environment light. Go to our HDRI here. We pick this one in the center. One thing that I want to do also before I start rendering is I want to hide that background. So we're going to change this to dark and click off on display environment so that way we don't see the background. Turn off our grid and let's see what we're looking at here. We're going to go to Karma XPU. Give it a moment here. And let's actually bring down our dome lights to 0.1. And it looks like you're having some sort of artifacting here. It seems as if there are times when Houdini does freak out a little bit and it was showing sub-O geometry. What we can do to fix that is we can go to our labs and reset viewport. Whenever we get funny looking things on our Houdini scene, if we do a labs reset viewport, it should fix whatever it is that we were experiencing, but that's only after you've troubleshooted and you went through your whole entire scene only to find that everything was working. Sometimes that does tend to happen. But yeah, if you see here in our scene, it is getting our gumballs and it is applying some of them to be emissive and others not. So yeah, so our materials are working the way they should. Perfect. Now let's go ahead and finish up with our scene here. We're going to drop a null and we're going to just call this lights. Control C, Control V. We're going to start setting up our camera. I'm going to drop this in here. We're going to rename this to render cam. And then finally, we're going to do a render geometry settings. The reason we're dropping a render geometry settings is because these gumballs have an emissive material and they need to be treated as such when rendering. So that way we can further optimize our scene and have it render a little bit quicker. So what we can do here is put in our import gumball active, click and drag into our primitives, go down to our light, set or create, treat as light source. Yes. So now these should render out a little bit quicker. Our scene is already fairly lightweight, but it's treating all of my emissive materials as a light source. Perfect. Now, one more thing that we should do is bring in our static gumballs. And one more thing that we need to do is go into our assign material. And under our active, we're just going to change this to an asterisk. And that is a Houdini wildcard, basically stating that as long as it has /environment/import gumball, whatever comes after that wildcard, that asterisk, apply this particular material and or action to whatever it is that you're doing. So if I were to press enter, now you're going to see that my material is actually going to be applied to my static gumballs as well, because they have that same first half of their name. So just give it a moment here to cook, and there it is. So let's say, for example, if I were to go into my Karma XPU again, yes, so the material got applied. The only thing that they are not emissive is because we did not add our emissive attribute to our static gumballs. So that is a perfect example as to why the top ones are emissive and the bottom ones aren't, and it is because of the attributes that we created earlier on. So let's go ahead and finally set up our camera here really quick. Let's just go ahead and have it at a point where they're all already moving around in our simulation. We can go to our render cam. We're just going to bypass our static gumballs one more time, so that way we can move about our scene a little bit easier. Let's go ahead and set up our camera here. Could do something like this. You can move it about to be whatever it is that you like. If you want this to be something cool for Instagram, you can change your aspect ratio from 16:9 to 9:16, so that way it has the aspect ratios of your phone. Also, the reason you see it disappearing here is because of my clipping. So let me just change this till it's 0.1, and that should fix that. And you can have something cool for Instagram. You can move these cameras in. You could do something pretty cool. We're gonna bring this back to 16:9. Move this back out. And then we can play around with our focus. So we just change this to camera XPU. I don't want to see my lights. I just want to see this. We can, let's say we can bring this in maybe like around here, right? Let's say we have it here. Go to our sampling. And one thing we can do here is, let's say our focus distance, we can change it to something like 1.2 and our f-stop to something like 1.5. That starts to make things blurrier, and our focus distance is basically where we want it to focus. So if we were to move this up, you can see that my in focus starts getting a little bit further away. The closer I bring this into the camera, the more in focus these closer items are going to be. The f-stop determines how blurry they're going to be. Now, one more thing I want to do is, I noticed that my spheres are a little tessellated, so I do want to increase that resolution really quick. So we're back here in our geometry context. Into our spheres that have the active gumball, we can change our frequency from 2 to 10, and they automatically become higher resolution because they're being read in here later on, and they're moving about in our scene the way that we want it to be. Perfect. Look how cool that is. Cool. So let's go back into our stage context. Right here. Render this again. And yeah, now our spheres are looking really nice. We want to go ahead and drop down a karma setting after this. And we can change this to be, let's say 1920 by 1080. At our XPU parameters of 128, so we could see that. And I want this to read in my render cam, so we're just going to go into free really quick. Change our karma render settings to something like final gumball render. You can change this to version 1 just in case of anything. Same thing that we did with our cache in the previous video, we're going to do the same thing here for v/. And our engine settings is going to be our XPU because we're rendering with XPU. Our path trace samples is just how high res we want this to be. So right now it's at 128. And even at 128 and 1920 by 1080, our scene is rendering at 13 frames per second. So we can increase this a little bit. I mean, it really depends on your computer, but you can increase the resolution of your scene a little bit. You can see here that by doubling my my resolution, it is taking a little bit longer to render my scene. It's looking at about 30 seconds, give or take. But yeah, you can animate your camera, you can move it around, you could create it at a different aspect ratio. In this case, I'm going to leave my static gumball alone because in this particular angle, we don't necessarily see it, but do keep that in mind that if you were to move your camera angle and you see pits that are voided on the bottom, you would need to bring in that static gumball geometry into the scene. But other than that, once you have everything here, you can set your frame range to be whatever it is that you like it to be. You could be 168, or you could be 240, it could be whatever you like. One final thing that I wanted to go over was we want to look at this at an ACES color space. So if we were to click on our eyeball here, click under color correction, and under untoned map, we change this to ACES. You'll see here that our scene got a little bit darker, but we can go ahead and just change that. We can up our light source here a little bit. We can just increase our lighting just a tad. We're going to composite this later on, so we want to make sure that we are outputting our renders in the ACES CG color space. So we click on here, we click ACES CG, and once we render this out, we're going to bring this into Nuke, and now we're going to composite it. So we are in Nuke. This is a rendered sequence of the scene that we had that you see here for the promo. It's looking a little bit different from our render, and that's because we have to go into our ACES color space. So if we click S here on our node, we go to color, we change this to OCIO and ACES 1.2, and this should be looking back to what we had it in our scene, and we can start compositing this to be an interesting shot. We're not going to do a lot of compositing since we want this to be more of a Houdini based tutorial, but there's a lot of things that you could do here. A glow such as this one. This comes from Nukepedia, so you can download this. This is from Spin. So you could change the amount of glow that you want. You can be very much glowy, or rather not that much. You can change your intensity to, let's say, 5 if you want this to be really in your face. In this case, we can just bring this down a little bit, maybe increase the radius of our glow, not too much. Yeah, we could do something interesting like this. And we can maybe play around with our colors. So one thing that you could do in Nuke is if you press C on your keyboard, you drop color correct nodes, so you can play around with your colors. Our gammas are our midtones, and our gains are our highlights, so we can bring in our highlight just a tad. In fact, we can actually bring this in before our glow, so that way our glow is being more so on these bright spots here. So we can bring this to, let's say, 1.1. We don't want this to be too much. Okay. We can add things such as a chromatic aberration. So we have things like thematic, also from Spin. So we just drop this in here. It's a bit too strong, but we can put this to, let's say, 10. We can start getting that chromatic aberration, so that reds and blues and greens along our highlights. So if I were to turn this off and on, you see that they're being added on there. We can add it in a grain. So let's say, once again, grain advanced by Spin. Maybe change this down to a little bit less noticeable, so we can just bring this down to lesser numbers, and then that's our size, and we can go to our intensity, and we can play around with these numbers here. If we actually start going into zooming in, we'll start seeing that we're adding some grain. And then finally, we can add something interesting like a vignette. So we can add in another color correct. We can add in a roto, bring in our mask, put this in here, and then I want this to be more of a circle. So we can click on here, click and drag, bring down our gain, and obviously it's going in the opposite direction that we want it. But before we do that, we could do a blur, and then we can increase this to, let's say, 150, or give or take, let's say 250. Let's increase this just a tad so we can put this here towards the corners. And then under our color correct node, we're going to go to our ranges. On our mask, we're going to invert, and we add that vignette on our scene. So it's not really a big compositing tutorial, but these are just some things that we can do to make our scene stand out a little bit more. So if I were to just to go over all of this and I press D, you see it looks a little bit more interesting if I were to do that. And finally, what you could do is you can add down a write node, and we could start writing this out to our particular file directory. We could do a .exr sequence or .mov ready for us to post. And one thing that we want to do, also very important, is in our output transform, make sure that we're writing this out to be an output sRGB. So we go to output sRGB. It's going to render out your file sequence in the exact color space that we're seeing here on our scene. But other than that, with that, you guys should be good to go. Now you have this really awesome scene. I love to see what you guys do with this. Post it on your social medias, tag me, like this video, comment, subscribe. Let me know what you guys think of it. Let me know what you guys want to see next. I love to see what you guys do with this and your opinions on this mini series. But other than that, I'll catch you guys in the next one. Peace.